In today's lesson, we are going to look at exploring graphs of periodic functions. So this is going to be the fourth type of function that we've looked at so far in this course. We've looked at linear and quadratic, which should be a review from grade 9 and grade 10. We've then also looked at exponential functions when we looked at the paper folding investigation, when we looked at the M&M investigation, and then partially in our assignment, we did touch on some exponential functions there. And this fourth one is the periodic functions. Now, we did cover this a little bit when we looked at our investigation into the Ferris wheels, but now we're going to look at some more characteristics and really clarify some of the terminology. So, periodic function, by definition, a function for which the dependent variable takes on the same set of values over and over again as the independent variable changes. So again, that's key. This last part here, dependent variable, takes on the same set of values over and over again as the independent variable changes. Now, a key thing here is this over and over again part. This is key because we have seen some repetition in some other functions before. We've seen them in quadratic functions, right? There is that symmetry on both sides, so we do see a repeat. However, the key for a periodic function is that we see this repeat over and over again, right? So it's not just a one-time thing. This occurs multiple times. And that's what's key with a periodic function. An example: the automatic dishwasher in a school cafeteria runs constantly through lunch. The graph shows the amount of water used as a function of time. So we see that the water filling up to a maximum. It runs for the wash cycle. It then empties, fills up again, maybe for the rinse cycle, and then empties. They then remove all the dishes and then put another in, start another load. So fills up to the max, runs for the wash cycle, empties, fills up again for the rinse cycle, empties. And it would repeat that every time you filled up, right? Assuming that you refilled it at a consistent pace and kept it going. Another example, similar to, again, well, very similar to the investigation we did previously, right? Looking at the individual's height above the ground as a function of time as they ride the Ferris wheel. So your height in a Ferris wheel is going to repeat, right? As you go up the Ferris wheel and as you come down the Ferris wheel. And as you continue to go around in a circle, you're going to hit those same points, right? You're going to hit those different heights. So it is going to repeat those heights. The key characteristics of a periodic function that we're going to be looking at are the cycle, the period, the axis, and the amplitude. So it's going to be some terms to allow us to more accurately describe our periodic function. So the cycle and the period kind of go hand in hand. The cycle is the smallest portion of the graph that contains the repeating pattern. So smallest portion of the graph that contains the repeating pattern and the complete repeating pattern. So not just part of it, the entire thing. The period is the horizontal distance required for the graph of the periodic function to complete one cycle. So it's the horizontal distance for one cycle. So if we take a look, I'm just going to highlight over it. So we have on the left, we have one cycle here in this wave. We can see that it starts at the x-axis and goes up, comes down, and goes back up to the x-axis, and then starts to repeat. So that's one cycle. We can also see that one period is the horizontal distance from the start to the end of our cycle. So in this case, our cycle takes 6 units. So our cycle is 6 units long. In this other example, basically to figure out to figure out the cycle, pick any point to start at, and just continue tracing until you reach that same point again. So in this case, this is one cycle. I also have another example where I could start here, go up, and come back down. So I can also have different looking cycles in the same periodic function, right? You just want to be careful at what you're looking at. The other key thing, the periods, the beginning and the endings of both cycles are the exact same. They're both 4 units long, which makes sense that in a periodic function that regardless of where you determine the cycle, the period is the same because it is that repetition. It wouldn't make sense that one cycle is longer than the other when it's supposed to repeat over and over and over again. The axis is a horizontal line halfway between the maximum and the minimum. So basically it's a horizontal line that cuts our periodic function in half vertically. So we can see it clearly in our example here. We have this midline that cuts right through, and it's halfway between the maximum and the minimum. Now we do have an equation to help us determine that actual value or where that midline occurs. And there, that equation is the maximum value plus the minimum value divided by 2. So again, nothing too tricky, relatively straightforward, I would think. The amplitude is the distance from the midline or the axis to either the maximum or the minimum of our periodic function. So again, midline is another word for the axis, which we just determined in our previous example, or in the previous definition. One thing to keep in mind, even though we're looking at the amplitude from the midline or the axis to the maximum or minimum value, it's always going to be a positive number. So it doesn't matter what those values are, it's always going to be a positive value, right? Because we're just expressing the distance in general, not the direction. Negative usually implies kind of a direction. So we can see here the amplitude. I'm going to highlight our midline a little bit clearer in green here, so we can differentiate it from other values. So we have our midline here. We have the amplitude going from the midline to the maximum. It could also be going from the midline straight down to the minimum. Either one is accurate. We do have an equation to determine what that amplitude is, to determine that actual number. Yes, you could count it if it's an easy periodic function. If it's not, it may not be the easiest thing. So that's why this amplitude formula comes into play. And the amplitude formula is the max value minus the min value divided by 2. So the key difference between the amplitude and the axis is adding the max and min value and dividing. The amplitude is subtracting the max and min value and dividing. So just a small change in operations gives us 2 different answers. So we're just going to practice on 2 examples. Given the periodic functions, we want to go through, highlight a cycle, state the period, amplitude, and the equation of the axis. So this one, the first one, is nicely done. We've already highlighted our cycle for us. So this is our cycle. To determine our period, it's the horizontal distance from the start to the end of one cycle. So in this case, it goes 1, 2, 3, 4, 5. So our period is 5 units. So our period is 5 units long. Next, in terms of our amplitude or equation of the axis, I'm going to find the axis first, just because then that helps me draw in the amplitude. Again, you could calculate either one. You don't need to calculate one or the other first. You can calculate either of them realistically. but just in terms of drawing, I like to draw the axis first and then the amplitude. So for the axis, it's the max value. Actually, I'm going to use blue for the max because that's not isolated for the axis. So we have our max value here. We have our min value here. Let me do it off to the side. Our min value there. So in this case, for the axis, we have 3 plus -1 divided by 2. We get 2 divided by 2, or 1. So that means that our horizontal axis, or our midline, is at 1. So I can draw a line right across there, and this is my axis. The amplitude then, again is the distance from the midline to the max or minimum. So our amplitude, very similar in an equation, except it is 3 minus -1 divided by 2, 4 divided by 2, or 2. And we can see that when we go from our max down to our equation, or our axis, sorry, it is a distance of 2, or from our axis down to our minimum, it is also a distance of 2. So again, it doesn't matter whether we're going from the line or the axis to the minimum or the axis to the maximum, it's still that positive value. One last example, we're going to go through and try to identify the cycle, period, axis, and amplitude. So to find the axis, or sorry, the cycle, I'm going to start and I'm going to at one point, and I'm going to continue until I reach that point again. So now I've reached the point again. So that means if I were to continue, maybe just use another color, if I were to continue, I would see the same pattern, but I don't. So because I don't see that same pattern, I do end up at the same spot, but I don't see that same pattern reoccurring. Right? I should be going up, not down again. That means we weren't done with the cycle. So let's go back and we're going to continue until we hit kind of a flat point, come down. Now, if I continue or use a different color, I can see that now I start to repeat that pattern. So you want to be careful because the pattern may be longer than you initially think. So I have multiple cycles in this graph right now. I'm just going to color them in just so we can see the difference. So this is one cycle, this is another cycle, and this is another cycle. So I have 3 or 2.5 different cycles, but they're the same cycle. They're going to have the same period, except for maybe obviously the last one because we only have a portion of it. But in most cases, if we can see multiple cycles, they will have the same period. Again, the period is that horizontal distance from the start to the end. In this case, we see that the period is 8 units. Start at 0, we get to 8. So that means the next one will go from 8 to 16, which it does. Right, so if we want to draw that in, another 8 units. Next, for the axis, we take the minimum value, the maximum value. So the highest point on my cycle is here. The lowest point is here. So for my axis, the highest point 5 plus the lowest point 1 divided by 2. We get 6 over 2, or 3. So that means that at 3, so 1, 2, 3, I have my axis. And in some cases, like it is here, that axis may be almost very a common almost line in our function, we can see that it does kind of level out there. May not be the case in every scenario, but we can clearly see our axis here. Finally, our amplitude. Again, same two numbers, max and min, except in this case we're subtracting and dividing. So 4 divided by 2 equals 2. So that means the height, or the distance from the axis to the maximum, is 2, which we can see that it is, or from the axis to the minimum, which we can also see that it is. So again, these are the key terms or terminology that we're going to use when describing a cycle. Oops, I have a typo here. So these are the four kind of key terms that we're going to use when we're describing a cycle, or not a cycle, a periodic function. Cycle, period, axis, and amplitude. And again, make sure we understand what they are, and in terms of the axis and the amplitude, how to calculate them.